Imagine trekking through the snowy, serene landscape of one of North America's most famous volcanoes, Mount St. Helens. The air is crisp, the view is breathtaking, and everything seems frozen in time. But then, you see it. A gaping dark void in the middle of a glacier. A massive, mysterious ice hole that seems to lead into the very heart of the mountain. This isn't a scene from a science fiction movie. This is a real and recently discovered phenomenon that's baffling scientists and exciting adventurers around the world. What is this colossal pit? Where did it come from? And what secrets does it hold in its icy depths? Today, we re-journeying to the Pacific Northwest to uncover the story behind the giant ice hole of Mount St. Helens. Before we descend into the mystery, let's set the scene. Mount St. Helens, located in Washington State, is an active stratovolcano, forever etched in our collective memory for its catastrophic eruption in 1980. That eruption blew the top 1,300 feet off the mountain, creating a massive, horseshoe-shaped crater. Over the decades since, this crater has become a cradle for new life and new geological wonders. Glaciers began to form and grow within the crater's protective walls, a process that continues to this day. These aren't your typical valley glaciers, they're crater glaciers, some of the youngest on Earth, relentlessly creeping and shifting over the hot, restless ground of an active volcano. It's this unique and dynamic environmental dance of fire and ice that sets the stage for our incredible discovery. The hole itself was first spotted by pilots and mountaineers, but it wasn't until scientists from the U.S. Geological Survey and other institutions got a closer look that the scale and significance of this feature became clear. Located on the crater glacier, this is no small fissure. We're talking about a massive opening, large enough to swallow a multi-story building. Initial observations revealed it was a Milan, a French word for mill. Milans are typically vertical shafts or channels that form in glaciers when surface meltwater finds a crevice and begins to drill its way down through the ice. The water, often warmer than the ice, carves out a tube, creating a natural plumbing system that funnels water from the surface to the base of the glacier. But the Milan on Mount St. Helens is special. What makes this particular ice hole so fascinating is its location. It's sitting right on top of a volcanically active area. The ground beneath the crater glacier is hot. Geothermal heat from the volcano's magmatic system warms the rock, and this heat radiates upwards. So, you have a double whammy effect. You have surface meltwater from the sun pouring down from the top, and you have geothermal heat melting the glacier from the bottom up. Scientists believe this combination is what created such a colossal and stable opening. It's not just a seasonal feature that opens and closes, it's a persistent gateway into the glacier's interior. Some have even nicknamed it the Godzilla hole because of its monstrous size. So, what's inside? This is where the story gets really exciting. A team of experienced scientists and speleologists, or cave explorers, decided they had to find out. Preparing for an expedition into a glacial cave on an active volcano is no small feat. It requires specialized gear, extensive safety protocols, and a whole lot of courage. The team had to be prepared for freezing temperatures, shifting ice, potential gas releases from the volcano, and the sheer unpredictability of the environment. Decked out in climbing harnesses, helmets, and ice gear, they rappelled down into the darkness. What they found was a wonderland of ice. The interior wasn't just a simple vertical shaft. It was a complex network of caves and tunnels, a subterranean world sculpted by water and heat. The walls were lined with breathtaking ice formations, delicate ice crystals, massive icicles, and fluted patterns carved by flowing water. The air was still and cold, and the only sound was the drip, drip, drip of melting ice, a constant reminder of the dynamic forces at play. Light from their headlamps bounced off the crystalline surfaces, creating an ethereal blue glow. It was like exploring another planet. But this expedition wasn't just for adventure. The team was on a scientific mission. These ice caves offer a unique natural laboratory. By studying them, scientists can learn so much about the volcano and the glacier. For one, the caves provide a direct window to the base of the glacier. Researchers can observe how the ice interacts with the hot rock below. This helps them understand the glacier's movement, its rate of melting, and how it might respond to future changes in volcanic activity or climate. The meltwater that flows through these caves eventually exits the glacier, and its chemical composition can give clues about what's happening deep within the volcano's plumbing system. It's like taking the volcano's pulse. Furthermore, these isolated, extreme environments could be a potential habitat for life. Scientists took samples of the water and a thin layer of dust and sediment on the cave floor. They're looking for extremophiles microbes that can survive in the harshest conditions imaginable. Think about it: total darkness, near-freezing temperatures, and a chemical soup influenced by volcanic gases. If life can thrive here, it gives us clues about where we might find life elsewhere in the solar system, like on the icy moons of Jupiter or Saturn, which are thought to have subsurface oceans warmed by geologic activity. The caves of Mount St. Helens could be a model for extraterrestrial habitats. The discovery also has implications for hazard monitoring. Mount St. Helens is still very much an active volcano. Understanding its plumbing, both for magma and for water, is crucial for predicting future activity. A sudden increase in meltwater from the glacier could be an early warning sign of rising geothermal heat, potentially signaling that magma is on the move. By monitoring the Milan and the water flowing from it, scientists at the Cascades Volcano Observatory can keep a closer eye on the volcano's vital signs, helping to protect the communities living in its shadow. The giant ice hole isn't just a curiosity, it's a critical data point. Of course, the future of this magnificent feature is uncertain. Glaciers are, by their very nature, always moving and changing. The crater glacier continues to grow and flow, and the volcano beneath it continues to breathe. The ice hole could one day collapse or change shape, or another one could form elsewhere on the glacier. It's a temporary window into a hidden world. That's why the research being done now is so important. Every measurement, every photo, every sample collected is a precious piece of a puzzle that we're only just beginning to solve. The story of the Mount St. Helens ice hole is a perfect example of how our planet is still full of surprises. Even in a place as well studied as Mount St. Helens, there are new wonders waiting to be discovered just below the surface. It's a powerful reminder of the complex and beautiful interplay between the forces that shape our world, of the creative power of destruction and the dance between fire and ice. It shows us that exploration isn't just about venturing to distant lands. Sometimes the greatest frontiers are right here, hidden in plain sight. So, the next time you look at a picture of a snow-capped mountain, remember what might lie beneath: a hidden world of caves, rivers, and secrets waiting to be explored. The Godzilla hole of Mount St. Helens is more than just a hole in the ice. It's a gateway to understanding, a natural laboratory, and a source of pure, unadulterated wonder. Thank you so much for joining me on this incredible journey into the heart of a volcano. If you found this story as fascinating as I do, please hit that like button and subscribe for more adventures into the mysteries of our amazing planet. What do you think is the most interesting part about this discovery? Let me know in the comments below. See you in the next video.